Hello, Intro to Ag students. Today, coming all the way to you from Scottsbluff, Nebraska, I will be trying to give you a little bit of background about macroinvertebrates so you're ready to kind of understand why I'm having you get so many pictures. Tomorrow when we go seining, we want you to be able to try to identify at least 3 of the organisms. So we have a whole bunch of pictures of all the different organisms that we caught before, and hopefully you can at least catch 3 of some of those. And I bet you can catch a lot more. So what I'm going to do today is go through a little PowerPoint that helps answer some questions that was developed and to check for some understanding so that you're kind of connecting why there are different insects in water. So our first objective is to identify the breathing structures. The major reason why we have differences in water quality is due to oxygen levels. As oxygen levels increase, you get better insects. As oxygen level decreases, you lose those better insects and you're down to insects that can handle poor water quality. And so the macroinvertebrates that live in water are reliant on how they breathe. On the website, there are on that PowerPoint, there's A through E, and there's a picture on the third slide that identifies the breathing structures of macroinvertebrates. Letter A is a mayfly, and with these little mayflies, they have to have very high water quality. The high water quality is related because all the mayflies can breathe with are the circled structures there. Those are their gills. They actually have gills just like fish, and that's all they can breathe with. The next one over, letter B, is a midge, and they're kind of like a mosquito larva where they have a mouth with gills on it. Those little hairs coming off are also gills. But if water quality gets really low, these midges and mosquitoes can actually migrate to the top and breathe in some atmospheric oxygen, but they can also breathe underwater. So B, you're going to find midges because they can do both. They can breathe atmospheric oxygen and they have gills. It's one of the reasons why there's lots of mosquitoes in the world, because they kick butt. They can do both. They have cool adaptations. The next one is letter C, and that's what's called a rat-tailed maggot. And what they have is a cool thing called a siphon tube. That circled item there, they can be in the water, and up to about 1.5 feet long, they can stick a tube up into the top of the water and bring in atmospheric oxygen that way. Letter D is a water strider, and those little guys don't breathe underwater. They just live on the top, and they breathe in atmospheric oxygen on the top, so they don't really care about the water at all in their adult forms. Letter E is a predaceous diving beetle, and what I circled on that one was a trapped air bubble. So in poor water quality, these little predaceous diving beetles can actually grab air from the atmosphere and then go down and swim around with that until their bubble's gone. And then they go back up to the top and they breathe in through their abdomen that another air bubble. And so letter D and E basically just breathe oxygen from the atmosphere. Letter C also does, but letters B and A can breathe mostly the water, and B can do both, and A can only do the atmosphere or the gill breathing under the water. So, checking for understanding, you should be up to on your quiz to about, I don't know, 7 or 8 in that range. It's not really a quiz, it's more of a worksheet. And that takes you to the next objective. Slide 4 says connect breathing structures anatomy with water quality tolerance. So, still on that macroinvertebrate anatomy PowerPoint, where you go to slide 5 and it's the same picture, but now we want to connect how these breathing structures relate to water quality. Letters D, C, E, and B can do either. They can breathe atmospheric or they can come down and breathe in the water. So they're actually more adapted to survival than what A is. A, if there's no oxygen in the water, it's not getting oxygen inside of our water, and it's stagnant, they die because they can't breathe. So A, our mayflies, because they only can breathe with gills, they are very intolerant, meaning they can't handle bad water quality, and they are then a sign, if you have them, that you have good water quality. That's what I wanted to connect today with water quality. Please make sure you have all of your pictures gotten so that when we go seining, you'll be able to look at your pictures afterwards and connect one of those insects. And then we can also now, hopefully, after filling out the Google form, you're able to listen to this lecture, look at the pictures, and also fill out the form, or the macroinvertebrate anatomy form, so that you can understand that I'll get excited when you start to find the good water quality bugs, the ones that indicate that they only can breathe through gills. I'll get excited when we catch those little guys. Now that we're done with this, the last objective for today was to do some more AET. On slide 7, it has a picture of the screen and it says AET down, and it's dealing with the SAE entries, and I want you to follow that little Google Doc, and it'll give you information on how to fill out more on your AET. And so as I get ready to leave here, please make sure that your pictures are done, then move on to figuring out breathing structures and how they relate to water quality. And the last thing is start working on some more of your SAE for your AET. If you have trouble logging onto AET, I might be able to look at my email tomorrow during your period. I might not. It depends on if we have cell phone reception out here in the West. Thank you very much, and good luck.